For this challenge, we have used SQL Server Engine to integrate and manipulate data, Microsoft Excel and R to make some additional data transformation, and Tableau, which allow us to make the final version of our plots. Here, we can see some details of the SQL Server tables, in which we both extract and filter data along 2 weeks. It's important to remark that Tableau allows us not only upload and visualize all the events we were obtained, but also to visualize patterns and behaviors along the 2 weeks of network activity. Okay, the start point in the analysis is to reach a general point of view of the network activity per day and per hour. The metric that was chosen was gigabytes. To get this, we believe the best option is to use heat maps. As you know, a heat map is a technique very useful to show big data. Heat maps allow us to conclude that the higher network activity takes place in April 12th between 7 a.m. on clock in the morning and 7.5 hours in the morning. On the other hand, the bars plots, in a new attempt to plot the network activity per hour and per day, we assume the principal network activity will be shown in business hours. In a new bar plot, we detect an unusual high network activity in the night in some days. We decide to use the VB content field section of the Big Brother table as a metric, uptime for servers by site. This metric provides the time that the server was up since its last status report. This metric was used to obtain information about the servers that the suspect down along the 2 weeks to get more service pattern behavior. Here, we can see clearly in the range between April 6th and 7th, all the servers are rebooted. Similar situation to 12 and 13. In fact, between the 7th and 10th, this fact happened too. But the problem was that we have no data in April 8th and 9th. To visualize this use percent along the 2 weeks, we decide to use bubble plots as a better option than others, due to it was easy to visualize the status changes. The server administration disk reached the 100% in 11th day. Similar to this, the web server 1, site 1, reached the 96%. Due to we need to have evidence about the external attacks to the servers, we focus on messages like this use or down status. Therefore, we get this target using text mining techniques. We parse the VB content fields of the Big Brother table, implementing a simple word frequency to get the outlier records. We built a VB content tokenizer with words meaning dictionary, and we create a frequency inverted plot, and the new event was found. Type of plots, a simple colors table, help us in our analysis. With this simple color table, we can detect a suspect area that by numerical IP addresses shown relation with the site 2, 100 workstations. This issue involves IP area addresses were not included in the big marketing list. On the other hand, with the Big Brother reports records with reference to connections. We can see the text servers with connections successfully registered during all the day. As an example, the web server 10.44 of the site 3. At the end of our test, we assume several issues which the evidence lack are not sure. Some of these have relation with the incomplete and inconsistent data provided. Local threats which we detect are supposed suspect activity into the big marketing installations. As a network administration role, we have built a timeline report to show the most important events. The visual timeline will report each week all the events that we have focused on it. The visualization role is not only very important to show events in several scenarios, but also we can find strange patterns and of course offer possible solutions too.